Welcome to our expert workshop on process bus in transmission, substation, grid operators experience. You will receive today valuable information designed especially for substation protection, operation, and maintenance engineers. My name is Jose Malagon, and I'm happy to be your moderator for this webinar. I'm giving you a virtual tour through this webinar for process bus in transmission substations, grid operators experience. My colleagues have prepared the following agenda for this webinar. We are going to start with the introduction to process bus technology. Then we will learn what things are new in the Ciprotec 5 process bus application. And then at the end, we will share an experience of the grid operator Luz del Sur building digital substations. And since we receive one question very frequently, I will say, yes, we are going to record the webinar and make the recording and the slides available to all the people that are going to participate in this webinar. If you already joined to one of our last energy automation webinars, you already know the questions and answers field in the application. Please type your question to the presenter and I will be your voice and ask Andrews, Orlando, and William directly after his presentation and during the live system session. In addition to my reading aloud your questions, you could also chat with our experts, Andrews, Orlando, in the background. During the presentation, they will write the answers in the chat. We will try to answer all the questions, but sometimes we have a lot of questions and then we will answer later by email if we are not able to answer the complete questions. Please take care of the following limitations. The chat is available in live mode. Only questions and answers will be answered via mail if not managed during the live session. And just in case you are in full screen mode, please press escape to see the question and answer and chat box. And now, let me introduce our experts. First, here we have with us Orlando Aquije. He is a key account professional at Siemens Peru, an expert in energy automation systems focused on transmission and distribution grids. He began his career with Siemens Peru in 2012 as solution engineer commissioning power automation systems. Their next roles have given him a deep experience at teams leadership and the deployment of technologies which help our customer to develop sustainable and innovative solutions based on digitalization with our Ciprotec, CCAM, and IoT portfolio. Also with us, Andrius Stamkauskas currently works as business developer for transmission and generation vertical. The last 3 years, he was promoting digital substations focusing basically on process bus technology. During that period, he has gained knowledge about different market requirements together with Siemens experience building digital substations based on process bus technology. Overall, he has more than 10 years experience selling Siemens energy automation products and solutions. And our special guest, William Kaman, is project engineer with more than 10 years of experience in the energy sector. He worked in hydraulic and thermal generation plants and participated in energy transmission projects. In the last year, he has managed automation and digitalization projects of high voltage electrical substations in the most biggest utility company of Peru. Together with a team, he has managed to put in service 9 completely new substations, in addition to further extensions and modernizations of existing substations. This has been the largest infrastructure expansion campaign carried out by the company so far. Andrews, as we are curious to learn more about process bus and want to hear about the experience of the grid operators with process bus, the stage is yours. Welcome, Andrews.
Thank you, Jose. So let's start from introduction to process bus technology. Let's take a look at substations, how they were built up to today. So previously we had primary equipment, we had copper cables, which we used to transmit signals from primary equipment to the control room to connect them to protection relays. For signal transmission to substation control system or higher SCADA control system, we were using IEC 61850 Ethernet communication protocol. Now, with new technology of process bus, we introduce so-called merging units. Uh, so what is a merging unit? Merging unit actually serves as the same uh, converter to digitalize signals, which we had previously, copper signals coming from by copper cables in protection relay. So now this part is taken out and placed in separate device called merging unit. So this device now makes digitalization. So it transforms signals from primary equipment, analog inputs, current voltage measurements into digital, so-called process bus technology, which corresponds to Ethernet IEC 61850-9-2 standard. So now all these signals are transmitted not via copper cables, but via fiber optic cables. It means that basically we digitalize and close the gap previously, which part was not digitalized in substation. Now we digitalize it via merging units, and all these signals now are sent to protection relays. So this is the main change of process-based technology, which of course impacts substation and all other parts of substation quite heavily, which we will see. And of course, we will not use new technology if it doesn't bring any benefit for the customer. So if we take a look a little bit closer to our substation uh, protection block diagram. So if previously we had current and voltage transformers connected via copper cables to protection relays. Now, with merging unit, of course, we can do exactly the same. We can connect any current and voltage transformers to our merging unit, then to digitalize those measurements and send measurements to corresponding protection relays. And of course, new technology is not merging unit, but also new technology is so-called non-conventional instrument transformers or sensors. They can be different type of sensors, low power instrument transformers or optical sensors. So these sensors now act as current and voltage transformers previously. So they measure current and voltage, which we have in the bay or in the high voltage substation part. So like I mentioned, the output of a sensor can be either low voltage signal or optical fiber output, and we connect those outputs or those sensors to our merging units. Of course, the idea to have merging unit not in substation control room, but as we have high voltage substation, so we want to reduce the amount of cables in substation. So we of course want to connect merging unit as close as possible to the primary equipment. Everything else in substation stays the same. Basically, we just introduce new technology for process level to digitalize all those signals which we had in primary equipment. Of course, we would like to, or we could speak immediately about cost savings. What kind of cost savings customers can expect or to achieve? So, of course, because almost no copper cables are used anymore in substation. Of course, we have some cables which are power supply cables to operate the circuit breakers, earthing switches, and disconnectors. But overall, almost no copper cables are used anymore. So we don't need such big cable trays as before. So they can be reduced in size or maybe even substituted with simple plastic pipes. So it means that we will need less materials and civil works. And of course, we can make reconstruction or substation renovation much faster. Merging units could be mounted, of course, in field in existing primary equipment control cabinets, if it's allowed, there is a space, or separate outdoor relay cabinets. We call them SAMU, standalone merging unit cabinets, as close as possible to primary equipment. to reduce or to have as less as short copper cables, because we still have to connect primary equipment gears to measuring units. As we almost do not have copper cables in the field anymore, we do not have to commission and make maintenance of them. So we have additional cost savings. So, and of course, our substation becomes more reliable, as for example, in case of fiber optic cables, if it will be damaged, it will be noticed immediately by either protection relays or switches or communication equipment, which we will have. So I would say this is the main benefits for using process bus in the field. Now, if we take a look in the control room, what are the benefits of using process bus? So, of course, in control room, we will have less relay cabinets as before, because multiple protection and automation functions now can be executed using less relays. Also, there are no terminals and copper cables in relay cabinets like before. So relay cabinets can be smaller because protection relays doesn't have binary inputs or binary outputs or analog inputs. They are placed in the field, as all signals from the field to control room now are transmitted via optical cables. Now we can combine, of course, also several bay protection relays in one cabinet because relays are smaller. We have much more space in relay cabinets. And also, less relay cabinets will allow us to reduce the control room size, and less land will be needed for such control room. Of course, we do not need any uh, installation such as double floor for cable, like before, for example, cables, because basically there is only optical cables now in our control room. And of course, such substation is much more safe to operate, as we do not have secondary wiring in control room anymore, so you cannot short circuit anything here inside. For if we take a deeper look at our measuring unit, we call it 6MU85. So we have one measuring unit which fits for all applications. So this is only one measuring unit which we have, 6MU85. So it is based on same Ciprotec 5 platform. So it shares also same expansion modules and communication cards like other Ciprotec 5 protection relays. Also, it can be expanded up to two 90-inch row rack. And as you can see, we have also same mounting possibilities, flush mounted, surface mounted, and also surface mounted with detached panel. Additionally, these merging units can be equipped with LCD display. Also, it can have push buttons for controlling primary equipment. So this merging unit also can act as bay control unit. Now, if we take a look about possibilities when we install this merging unit in the field. So our merging unit provides interface to various primary equipment, switching devices, all kinds of sensors, tap changers, Buchholz relays. So we can realize also additionally user logic here inside for field and bay interlockings. We can also make transformer, for example, cooling control. We can apply automatic voltage regulator. Also, we can execute some simple protection functions. So basically, this device also can be as a backup protection device, can serve as backup protection device in case control room or is on fire, for example, or something has happened with control room or communication. So as you can see, this is not just a simple device which converts signals, but it's also a smart device, basically almost same like our Ciprotec 5 protection relays with similar or almost same functionality. Now, if we speak about communication capabilities, so our one matching unit can be equipped with up to four process bus communication cards. Each card can have up to two streams. So in total, we can have 8 streams in one merging unit. Each streams can provide up to 32 analog values with flexible allocation of current and voltages to publish in accordance with IC 61869-9. Also, we can have same communication protocols as in any other Ciprotec 5 protection relay. Of course, we support redundant communication such as PRP or HSR, which is necessary to execute protection functions or protection of a primary equipment. Also, we can have phasor measurement unit feature in same merging unit. We support time synchronization according IEEE 1588 version 2. And of course, previously time synchronization functions as synchronization via pulse per second or ERIC-P. Also, we can equip our merging unit with such communication cards as ARC sensors, for example. So as you can see, there is really a lot of possibilities we can do uh, we have in one device, which is called 6MU85. So I would say this is just short overview of our features and benefits and functions which we have in our merging unit. Now I would like to forward presentation to Jose.
Thank you, Andrews, and thanks for the explanation related with the concepts of process bus. Now, I'm going to explain the new things that we have in process bus for the Ciprotec 5 family. The first topic that I would like to share with you is the topic related with redundancy. Now is available in our portfolio also the high availability SIM redundancy for the process bus application. We can have the rings here to integrate, for example, the merging units with the protection devices. That means, for example, here main one, protection one with the merging unit one in one ring, and maybe, for example, here also to have the control application with the bake control unit could be a case, and in another ring, for example, the protection two. Also with us and already in our previous development, the parallel redundancy protocol for the process bus application. The advantage now to have HSR, of course, is that we are going to have less ports in the switches. It's one of the biggest advantages when we are going to use high availability SIM redundancy. This is an example of an architecture that we have for high availability SIM redundancy. We have here the devices, okay? Here we have the red boxes that are going to permit to connect the grandmaster clocks to the network. For process bus application, it's important to have the sample synchronization through 1588 version 2 protocol to give the time to the different participants in the network for the merging units and for the protection devices. In that way, we can compare the samples at the same timestamp. The new functionality that we have here in our merging units and our relays is that we have now the transparent clock functionality that permits to have the HSR config topology. One of the questions that I had in the chat related with interoperability. If we have done, for example, tests with different manufacturers of merging units and our protection devices. And in some countries, we have done some tests to check the interoperability between our merging unit and protection for another manufacturers. And then, for example, in some countries, we have that the customers are using, for example, merging units in the field from Ciprotec and protection for main one from Siemens and main two from another manufacturer. There are some experience in the field from some customers. And to improve the interoperability now also, because not all the manufacturers support, for example, 61850 edition 2.1, we introduce now also in our application the client instrument transformer settings editor that permits to integrate merging units that does not fulfill 6150 edition 2.1. And then we can integrate easily this kind of merging units without change the SCD file. Basically, the SCD file remains the same. With this new structure, that means we can introduce, for example, the behavior of the merging unit when we have some transients, and the behavior is reflecting one setting. Now the setting is there available for different kind of merging units. The other topic that now we have in our portfolio is, for example, also the possibility to introduce the direction of the neutral current, the 3I node. It's not clear in the standard the definition of the direction of this current. And then in one of the subsequent editions, we are going to have that the neutral current is plus 3I node to grant the compatibility of the complete protection system. Now in our application, we can define the setting if it's minus 3I node or plus 3I node, according with the following the recommendation from the different manufacturers of marine units. Okay, that is also new in our portfolio. And a good news for us is that now we have a certification from MUCA related with 6150 edition 2.1. We are one of the first one worldwide with this certification. We are certificate with 6150 edition 2 with amendment 1 and 61A69 first edition part 9. That is really a good achievement for us because now we have the certification and we can grant our customers basically the interoperability following the 6150 standard. Okay, now we are going to have a poll question survey. Please, you are going to have this in the application. If you can answer, we will appreciate. Okay. Now I'm going to give I'm going to transfer the presentation to Orlando, and he is going to explain to us the experience with our customer Luz del Sur related with the digital substation construction, how they build these substations and what are they experience with digital substations. Also, we have with us William Caman from our customer Luz del Sur, that can share with us also his experience related with the digital substation construction. You can ask him in the chat if you have questions related with his experience. Okay, Orlando, the stage is yours.
Hello, hello everyone.
Orlando, you are muted. Oh.
Try now.
Uh, Could you please try again, Orlando? It seems that you are muted. Orlando, we cannot hear Orlando. I'm going to answer in the meantime some questions that I have in the chat. For example, here we have one question related with the HSR ring. How many devices in one HSR ring we can support? We can support 16 devices in the HSR ring. If the HSR ring brings or is broken, then we can, that is the advantage of the high availability in redundancy, that basically if one channel breaks, the other channel is available, and then the protection is still working. That means we have two channels to send the information. That is one of the advantages, and it is mandatory to have similar redundancy in the case of process bus. I don't know if Orlando is coming back. It seems that Orlando,
Yeah, he's reconnecting, I think.
he's trying to reconnect again. Uh, mm, how many CTs and BTs hardware input channels can be connected to a single merging unit? We can connect in a single merging unit 64 channels, but I will say in normal applications, in transmission applications, if you have the push bar protection, then you have the line protection one, then the line protection two. In transmission applications, usually you have one merging unit for main one merging unit for main two, and in the second merging unit, you can have, for example, also the push bar protection. The other application that is for transformers, for example, you can have the high voltage side, the low voltage side, and the tier side, and then in that way you can have at least, I will say, 20 channels in this kind of applications. But we support more. We support 64 channels. We are trying to get back Orlando. Another question. Orlando.
Hello.
Okay, Orlando is here again.
Hello. Sorry, I have some problem with my microphone.
Okay, then let's go to continue with Orlando and the experience with Luz del Sur building digital substations. Orlando, the stage is yours.
I start with this slides, okay?
Yes, you can start again from Luz del Sur experience.
Okay. Well, can you hear me? Yes.
Yes, we can hear you.
Sorry. Okay. Well, hello again, everybody, and welcome to this expert workshop in process back technology. And also say thank you again to customer Louis Sur for his invaluable contribution for this session. It's a pleasure for me to talk about Louis Sur experience in building a digital station specifically for set los houses. Well, firstly, I would like to introduce to Louis Sur. Who is Louis Sur? Louis Sur is one of the largest distribution system operators in Peru, which supply energy to almost 1.2 million customers in the southeast of Lima, which is the capital from Peru. Um, Sur is an utility which is currently expanding the high voltage network. Okay, and as a part of this expansion, he commissioning the Settlers Access Station in February 2020. Um, Now we talk about process bus implementation for Settlers houses. Okay, what about the solution for this project? As I mentioned before, in February 2020, Settlers Houses substation was energized in Lima in collaboration between Sur and Siemens Peru. This solution is based on an entire Siemens technology, specifically using our Ciprotec 5 platform, where as a core of the solution, we use Ciprotec 6 and U85 as a merging unit, okay, which Siemens supply 14 devices. And also,
Orlando, may I interrupt you? Could you please share your screen?
sorry, now it's okay.
Not yet. Now it's you have problems with your screen.
Yes.
Now it's okay.
Maybe. Okay. You can go on now. Thank you.
Can you see my screen?
No.
Okay. Well, uh,
Somehow we seem to have a problem. Please, Andreas,
I
can
can
we
share.
have your can you share please this the screen? Yes, please.
Yes, you just use it. I'm sharing.
Okay,
And you just tell me when I have to switch.
you have to move one forward, I think.
okay. I can see the screen from Andrews.
Great. Okay, so you can go on, please.
Okay, Andrews, please, next slide. Okay. Um, I was explaining about the solution for Ludesur set loss houses. As I mentioned, as a core of the solution, we use our Ciprotec 5 platform, which we use the devices XU85. Okay, we supply 14 devices as a marine unit and several Ciprotec devices as a control and protection. Which was included for solution for lines, transformer, coupler, and busbar differential protection. We also use here SICAN AQ3 as a RTU and SICAN SEC SCADA system as a system for the substation automation. We also supply 6 Raycon switches devices for the Ethernet PRP network, for process bus and station bus network. Okay, now in this scheme, as you can see, um, additional to our conventional solution for the majority of us, we can see the merging units and the bottom side. Uh, this kind of philosophy was implemented in each kind of base. As you can see, we have lines, coupler, and transformer, and each of one have two merging units. Okay, one merging unit as a main one, and a second merging unit as a main two, which also include the local control as a backup functions in case the protection relays fails on the network. The communication between these two kind of devices, merging unit and protection relays, is done by a process bus network. It's an Ethernet process bus in PRP topology, okay, where sample values and ghost messages is sharing between these kind of devices. And for this interconnection, we use a dedicated process bus network only for sample values and ghost messages between these two kind of devices. And also here we have a station bus PRP network in order to connect all the equipments such as protection relays and the station automation, and also, for example, for remote management of the devices. As you can see in this picture, we also have two clocks, which is grandmaster clock for the synchronization of the networks. And this solution, what was implemented is to install two clocks in a redundant configuration in order to increase the availability of the process bus network. When we use process bus, the clocks are a key device for the availability of the network. This is the case we use redundant configuration. Uh, One thing I want to mention is that if the protection relays need to send a command or a trip to the, for example, to secret breaker, this of kind of information is sent via the process bus network. This is a complete digitalization of the substation. Please, next slide, Andrews. Um, as I mentioned before, the scope of the project was to build two lines over 220 kilovolts, which here please is okay, which enable to interconnect set loss houses with an existing substation set industrials. One of the most highlighted point on this project was the implementation of a mixed scheme for differential protection. where the project implemented process bus technology in the new substation, set loss houses, and and for the for the en- for the sorry and for the inside, which is an city substation called set industriales, uh, we consider to maintain the current philosophy. Okay, the existing conventional scheme. The idea was to not affect the current philosophy of set industriales. As you can see, for expansion of the electrical grid network, we can implement a new substation using process bus with making alteration of the inside, for example, here as set industriales. Please, Andreas, the next slide. Can you hear me? Okay, nice. Okay, well, here we would like to show you the SAMU cabinets or merging unit cabinets which allocate the devices from the process level. And the project considered the supplying of one SAMU cabinet per bay, and each cabinet contains the merging units and energy meters. Um, as you can see, the merging unit at the upper side is the main merging unit, uh, which has a control local function as a backup in case of the failure of the protection relays. And, and also the cabinet has a second merging unit for which collect the information and send the information to the second protection relay. Okay, and well, for the energy meter, as you can see, we use an ion device which is installed on the process level, and he has a conventional solution and is connected directly to the station bus. Okay, the SAMU cabinets are mounted in the GIS room together to primary equipment based on GIS technology. Next slide, please, Andreas. Okay, in the control room, um, at this picture, you can see a control room, which is a small one, due to the solution based on process back technology, which enable to reduce the number of cabinets. How is possible? Take a look at the picture, and starting for the left side, you can see the substation automation cabinet, which contains, for example, the time synchronization, the grandmaster clock, the X3 redundant RTU, and the CCAN SSC as a HNI. And in the bottom side, as you can see, we have two switches for a station bus network. At the next On the next side, from the substation automation cabinet, we have a cabinet for process bus switches, which contain all the Raycon devices to connect the protection relays with the merging units. Okay. Next to this cabinet, you can see the protection relays for the substation, uh, as the whole electrical cables are not connected anymore to the protection relays. We can use protection relays with a compact solution, only with a CPU, for example, and one Ethernet card for process bus connection. And this enable to user to reduce the space on cabinets, optimize the space, and also to mount more protection relays per cabinet. For example, you can see that the third cabinet, beginning from the left side, we have the first row is for the protection line. The second row is for protection line one, sorry, line two, and the transformer one. If you can see the next cabinet, okay, on the right side, we have at the first row digital phone recorder. We also have uh, two relays for transformer 2, other relays for the coupler, and the last one on the bottom side is for bus bar differential protection. You can, with Proxy bus technology, you can um, optimize the use of space in your control room and also optimize the number of cabinets in this kind of room. Can you move the next slide, Andrew, please? Well, about the benefits from Ludusur, we can move uh, on these statements. For example, for less wiring, uh, we can replace miles of copper or copper cables with a cost-effective solution by using fiber optical cables. Okay, and this is a part also for save cost and and get a reduction from execution time. Now, as you don't need anymore to install a long distance of cables, you can make a new performance, a better performance for commissioning. Also, in terms of safety, due to the protection relays not connect electrical cables anymore, you can reduce the dangerous for voltage to the protection and control cubicles. Okay. Also, with process bus technology, you could get a higher flexibility because you are mounting or you are implementing a digital and interoperable solution when which enable to the customer make extensions in a easy way. Also, as I mentioned before, you can get a space saving, but as you can see in the picture before, you can obtain devices more compact, for example, in control and protection cabinets. Please, Andrew, the next slide. Okay, I would like to share with you some lessons learned from Ludesur, okay, and some conclusions. And process bus technology from Ludesur is a standard for implementation not only for greenfield projects but also for brownfield projects. Okay, one recommendation or one lesson learned in this kind of solution, if you are starting on it, is more easy to implement process bus network and station bus network physically separated in order to reduce the risks and make the task more easy for maintenance group. Okay, and also, if you get this kind of project, you also need to train to people in order to maintain and to know new procedures for operating this kind of protection and control system. As a recommendation, we need to do all kind of tests during FAT. For example, we did all the tests in Siemens factory, and what enabled us to reduce the time and execution time during commissioning. And this task based specifically for primary connection testing. And also, as you can see, we introduce a lot of knowledge of networks when you need to configure or setting up goose messages, sample values, which involve, for example, VLANs, MAC filtering, and implement this kind of documentation is very key. Please, can you change the picture? Well, I would like to share with you. Um, can you move? Yes, thank you. Siemens Peru, as experience, we implement in 2016 our first digital substation for two auto transformers and 200 kilovolts in high voltage, uh, where, where where we obtain this kind of expertise for executing this kind of project. Um, Since Siemens is a leader of ISC 6150 implementation around the world, we had to implement new skill based on skill networks, which more easy for us because we are very we use as a template this kind of implementation using IAC system one in fixed. And also we have to make an investment with our engineers because we need to make an upskilling and pack system and protection and automation system, including and applying setting up for VLANs and MAC filtering and so on. During the FAT, what we recommend is to implement the whole test of the protection and control system in order to minimize the SAT task test. Please, the next slide, Andrews. Um, Here, uh, I would like to thank to William from Lusur for sharing with us his contribution and experience based on set loss houses. This is his contribution. The process bus solution allowed us time saving during commissioning and site tests in our set loss houses substation, and also contributed to the development of new digital skills of our technical team. Sorry. And next, please, Andrews. Also, it's a pleasure to share with you our contribution based on the experience of working together with Lusur and Celos Access. We are proud that our customer Lusur is planning to adopt process back technology as the standard for the implementation of all these new high voltage substation. Uh, industry stringent safety and operation requirements can be met in more cost-efficient, compact, and a simple way. Well, thank you. This is for my part, and I come back to Jose.
And thanks, William, also to participate with us to prepare this presentation and to share with us the experience that you have in Los del Sur in the construction of digital stations. Now we have questions. I have a lot of questions, or we have a lot of questions in the chat and also in the questions and answer session. Let's go to check here in the chat. There are some interesting. William, is Luz del Sur here? Let's go up. William, is Luz del Sur planning to continue building digital substations? As far as I know, is the third one. Did you already decide to continue with the construction of digital substations?
Okay, hello. Good morning, everybody. Good morning from Peru.
Yeah.
Well, about the question, yes, it's a political for Luz del Sur now. All the system controls, the new system implementation of system controls for the future for the Luz del Sur is a should, is a must, digital technology with process bus. Is very complicated for us to return to the past and use the conventional. Maybe for the substation, the exist substations, the old substations. In this case, we use the conventionals because for the facilities, but all the new substation for us now and the future is a digital technology.
Okay. Thanks, William. There is another interesting question that I think is also for you and for Orlando, because the question is related with the time. Is it true that configuration and testing of process bus solution takes more time than conventional SAS system? Plus, not a lot of people trained for this job and taking in account cost of engineering and new equipment needed. Is it really true that the data savings made with replacing copper cables with fiber optics are reduced prices significantly? William, what is your experience related with time for commissioning and for execution of these kind of projects?
Well, about the commissioning inside, for
Mhm.
us, is a good solution
Yeah.
because we have a reduced time, a little time for the commissioning in the substations, because the civil works and electromechanical works has a long time or maybe has a delays, but the date of the put in service the substation don't change.
Mhm.
For us, it's important to get uh, this date, because we have compromise with the OSINERMIN, is the institution of the government that regulates the electrical system in Peru. We have approximately reduced in 50% the times in the put in service, because we have all the equipments arrives to the substation configured, and it's only necessary to connect the wires and the fiber optics. You turn on and you can test with the high voltage equipment, and that it's obviously the time is reduced.
Okay, thanks, William. There is another one. I think it's also for you. Sorry for that. Since Process Boss is now a business as usual for Luz del Sur, will will you all be single vendor solutions, or have you implemented any multi-vendor substations, and has this raised any interoperability issues?
Uh, this part of the technology,
Mhm,
for now, we can't testing. We have substation with other brandings,
mhm,
but mm, actually no interoperability in service or the equipments. For example, if the substation start with Siemens equipment, we try to continue with these devices
mhm,
until we have a testing that verify the interoperability of the equipment. For that, for this time, for this topic, we implement a laboratory in the installation of Luz del Sur. In this laboratory, we worked with Orlando and the other brandings, and implemented multi-branding
mhm.
equipment. But for now, it's testing for us.
Okay,
When we have the certain of this application is it's okay, well, no problem. We start to implement.
okay.
Mhm.
Uh, I think there is another for you, uh, because you are the important speaker here for us. Have you considered using LPITs? It's very easy with Process Bus. PM is asking uh, that
LP,
will LPIT or not conventional cities.
not conventional cities.
Yeah.
Well, I don't have the experience about that, but
Mhm,
if I if it's possible, it's a good solution with LP not conventional, because with that reduce more use of wirings.
yeah.
It's a good solution. I recommend it, but for I don't have experience now.
Okay, thanks, William. Well, I'm looking for more questions here. I have a lot of questions. Let me look through it. Uh, there is one question related with the, maybe Orlando can help with us, can help with that, related with the metering devices. What kind of metering devices we use here and where we install? Because could you please explain more about that, the metering devices that we use here? And because my understanding is that they are not process bus, no?
Yes, we use energy meter from ION, which technology ION. This is a conventional device, and this device was mounted in the process level cabinet or SAMU cabinet,
Mm-hmm.
and was connected directly to the station bus network, and only to send information to the RTU and after to the control center.
Mm-hmm. The
Mhm.
other topic was related, which RTU we are using.
For this project that was implemented in
Yeah.
2020, but the devices was both in 2019.
Mm-hmm.
We use the SICAN XKey3 technology
Mm-hmm.
in a redundant configuration using only one rack. This is another solution. But now we are implementing solution with our new SICAN 8000.
Mm-hmm. Okay. We have the other question for you, Orlando, and also maybe for William. Why we decide for PRP and in this configuration?
Okay, I could answer.
Yes.
Okay, well, this was a requirement from Lusur
Mm-hmm.
in order to increase the manipulation of the network when its maintenance crew uh, make maintenance tasks on the
Mm-hmm.
network. It's a more easy network to, for example, to make troubleshooting, to maintain, maybe for make some tests. But I don't know, maybe in the future, Lusur will decide to move also to HSR configuration, but this is was the reason for this
Okay.
kind of project.
And I think it will be one of the last questions. This is for also William. Does Luz del Sur also have air insulated switchgear stations? And will process bus also be applied to them? Do you see difference between air insulated switchgears and gas insulated switchgear? William.
Oh, sorry, Jose, I don't understand the first part of the question.
Yes, here the BD is asking if Luz del Sur have also air insulated switchgears and if process bus will be implemented also in air insulated switchgears in subestaciones en aire.
Ah, okay. Yes, we have implemented in technology of AI,
Mhm.
but this is with other mark, other brand.
Okay,
But all the works with Siemens is with GIAs
okay.
substations.
And the question was, do you see difference between air and gas insulated in the application of the process bus?
Yes, is well, we found a benefits for
Mhm,
the two models. For example, for the GIs switch gears, it's possible that you buy the substation with the LCC when with the LCC with the MUs implement in this cabinet.
mhm,
I think that this solution is better for GIs switch gears.
mhm.
And what about with the air technology? Is typical is know for us that the size of the area of the the construction is biggest
Mm.
than the other technology, and you reduce the use of cables, and you reduce the times for the installation of these cables. The two technologies has a good a good solutions, a good benefits. I think we have in the park of Luz del Sur, we have we implement in the two technologies.
Okay, thanks, William. Thanks for answer the questions. Thanks again for coming to this webinar. Thanks to help us to find the benefits for this kind of technology, for the process bus application and for the digital substations. Now for us, it's time to say goodbye. I appreciate that you all of you are joined to this webinar. Was really successful because we have a lot of questions. I have to say that we need to answer later on. We will answer by email. We will try to answer all. And I hope that you enjoy this webinar. We will say goodbye and thanks for coming. Stay healthy and bye. Thank you.
Thank you.
Thank you.